Hey guys, so this is going to be 6.3 day one. So hopefully yesterday went okay. Make sure you're asking questions if you're not. Make sure you turn in yesterday's homework today by 4 p.m. Um, now, this lesson might be one of the most important ones. I don't think it's particularly difficult, but it's probably one of the more important ones, ideas that you'll use in calculus if you're going on. So make sure we get this nailed down and make sure you ask questions if you do. But today we're going to use trig ratios to evaluate trig functions, and we're going to use reference angles to evaluate trig functions, okay? And so reference angle is also another important idea in which allows us to solve these trig functions. So moving on, basically this is a form of Pythagorean theorem. You have, well, let's get the pen out. If you had r squared, well, yellow is a terrible idea. R squared equals x squared plus y squared. How do you solve for r? You take the square root. So you have r equals square root of x squared plus y squared. Basically, that's the distance of r. And so we're going to be talking about ratios on a circle. My circle is terrible. Oh, goodness. But r is basically, we can consider it our radius, or it's the hypotenuse, okay? And so we've talked about the trig ratios in terms of hypotenuse, adjacent, opposite, but we're also going to talk about them a lot in terms of x, y, and r. And so if you can imagine, if we're talking about this angle, theta, the opposite of theta is y, and the hypotenuse is r. So that's basically the same thing, just another way to talk about sine. Cosine. X is adjacent over r, which is hypotenuse. Now again, I'm really sorry about this watermark, guys. That's annoying. That drives me nuts. But this says tangent. So tangent would be opposite over adjacent. So y over x. Cosecant, opposite of sine, reciprocal, r over y. Secant, reciprocal cosine, r over x. Cotangent, reciprocal tangent, which would be x over y. So I would write those down. Sorry. I believe I told you when we talked about sine is opposite over hypotenuse, yada yada, that they're going to be on a test, which they are. So sometimes I'll ask you to write them in terms of y, x, and r. Sometimes opposite, adjacent, hypotenuse. Sometimes both. But they're on almost every test that I can think of. So it's important that you have this written down. Feel free to pause me if you need time to catch up. Now, we're talking about trig ratios, okay? And so it's important to know when these are going to be positive and when these are going to be negative, because they can be negative. So in quadrant 1, all of them will be positive. Sine, cosine, tangent, cotangent, cosecant, secant. All ratios will be positive in quadrant 1. In quadrant 2, only sine will be positive. All the others will be negative. In quadrant 3, tangent is going to be positive. All the others in quadrant 3 will be negative. Well, it is important to clarify. If sine is positive, if you have a positive fraction, and the reciprocal, which would be cosecant, that would also be positive, right? So cosecant would be positive here, and the opposite of, or the reciprocal of tangent, cotangent would be positive here, okay? That is an important clarification. And then cosine in quadrant 4 will be positive, meaning that, secant will be positive in quadrant 4 as well. And so the acronym we use to remember this is all students take calculus. All, A, all of them are positive in quadrant 1. And then students starts with an S, so does sine. So sine is going to be positive in quadrant 2. And then take, tangent, starts with T as well. tangent will be positive in quadrant 3, and then calculus C cosine. So in quadrant 4, cosine will be positive. Okay, and so I would pause this and get this written down. I'm going to erase this for a second. Let's see if it's still, oh goodness. And so I just want to draw a couple triangles just to kind of demonstrate. I mean, I imagine it could be quite confusing right now. But let's say we have a triangle over here, right? And we're thinking of it almost like it's on an XY graph. So your height, hopefully we know, is going to be positive. So let's say this is positive 5 because you're going up. So our Y value would be positive. Our X, however, you're going left on the X axis, so it'd have to be negative. So I don't know. Let's just say 4 for the heck of it. Okay, so if you can imagine, then sine, well, 25 plus 16 equals the r squared. So 25 plus 16 gets you 41 r squared. So this would be the square root of 41. So this is always going to be positive. The r will always be positive because it's almost like our radius. Our x and our y can be negative depending on which quadrant they are in. So x will be positive, or x will be negative here. So if you can imagine sine of this angle, it would be opposite over the hypotenuse, or y over r. That's going to be positive, right? And so would cosecant, because cosecant would just be reciprocal of that, square root of 41 over 5. But all the other trig ratios are going to involve this. So cosine, you'd have a -4. Secant, you'd have a -4 in there. Tangent and cotangent both involve this, okay? And so that's how sometimes they become negative. So it's important to remember that. One thing you could do is at the end of solving a problem, so if you have a triangle here, you solve everything, and you're looking for sine, you got to know that sine's negative here. So you could tack on a negative at the end, or you could just realize, well, our x has to be negative, our y has to be negative. Now, again, the r is always going to be positive, so it'd be positive 41, but sine would be opposite over hypotenuse, or y over r. Okay, and so some of these trig ratios will be negative. It's a neat little, is that an acronym? I think so. So remember, all students take calculus. Moving on. So now we have an idea called reference angles, okay? And the way I describe it, let's see if I can scroll down a little bit. The way I describe it is it's basically the closest angle, closest way to the x-axis, okay? So if you have this, I don't know, let's say this is a 120-degree angle, and so you go over here. The reference angle is the closest angle to the x-axis, okay? And so hopefully it's obvious that this way to the x-axis is a lot closer than going backwards. So this is going to be our reference angle. Now we need to find what that reference angle is usually. And so hopefully you know that if two angles, what do we call it, supplementary angles, they have to add to 180, right? So you could do 180 minus 120, which would get you 60. So your reference angle here would be 60 degrees, okay? Now if you're in quadrant 1, so we have this angle, I don't know, let's say it's 60. The closest way back to the x-axis would be right here. So our reference angle is our angle, okay? So we don't need to subtract anything. So in quadrant 3 then, if you have, I don't know, let's say it's a 210 degree angle. We want the reference angle is basically the angle closest to the x-axis, so we want to go back to the x-axis, which would be this angle right here, right? And instead of going all the way around here, it's going to be this angle. And so the way we do this is you do 210 minus 180 then. Okay? And that would get you 30 degrees. So this reference angle would be a 30-degree angle. Okay? And last but not least, if you're in quadrant 4, let's say we have a 300-degree angle. Why not? So we go all the way around 300 degrees, and our reference angle is going to be the closest way back to the x-axis, which would be this angle right here. We don't want to go backwards, that'd be longer. So this is going to be our reference angle. And so we can do 360, which is the total degrees around the circle, minus our angle, which is 300. So our reference angle would be 60 degrees. Okay? So you can pause, get that stuff written down. Examples, let's scroll down a little bit. Let's find reference angles, okay? And so maybe you're a visual person. I'll draw our typical XY graph. Now we're going to have a 110 degree angle, which goes over here 90, and then 20 more. So that's our 110 degree angle. And so we need to mark the reference angle and find a reference angle. Sorry. So reference angle, again, closest way to the x-axis. The x-axis is the horizontal axis. And so the reference angle will just be this right here, right? So we marked the reference angle, which on your test, which may happen, may not, who knows. I do ask you on one of the questions to mark the reference angle, so it's as simple as what I just did. Just draw that little angle thing, arrow, I don't know. Just mark it so I know you know what you're talking about. But then you want to find the reference angle. So we just do 180, which we know an angle all the way over here would be 180, minus 110, and you would get 70, right? So our reference angle right here is a 70 degree angle. Alright, let's do 295 then. So you go over 90, 180, 270, and then you go over 25 more. Okay, and so there's our 295 degree angle. We had to find a reference angle. The closest way to the x-axis would be this one right here, so I just marked it. Then we gotta find it. So you do 360 minus 295. Okay, and then you plug that in. Hopefully we can do that in our head, right? You get 65 degrees. So this would be a 65, oh boy, nice 65 degree reference angle. So it's important to note, is it on the next slide? Yeah. To find reference angles, in quadrant 1, now this little thingy right here, that's just the reference angle, okay? So the reference angle equals the angle in quadrant 1. We talked about that. In quadrant 2, to find your reference angle, you do 180 minus your angle. In quadrant 3, your reference angle equals your angle minus 180. And in quadrant 4, the reference angle equals 360 minus your angle. Okay, so it's different depending on which quadrant it is in. I don't think it's necessarily difficult. I think you can just realize it's the angle closest to the x-axis, so you have to subtract something from another thing to get that, right? I know you guys are capable of that. So write this down if that helps you. So let's get into the purpose of this. Okay. Actually, let's keep finding reference angles for a second. Sorry, I just got a weird email. We need to find the reference angle of these, and so I'm going to go through these kind of quickly. Terrible. 250, you go over 90, 180, you go over 70 more. The reference angle is the closest way back to the x-axis, so it's this one right here. So you gotta do 250 minus 180. Okay, and you get 70-degree reference angle. Okay, 5 pi over 3. Well, honestly, I would just recommend converting 2 degrees. So let's erase that because that looks a little sloppy. Pi's cancel out. 30 goes into 180 60 times. 5 times 60 is 300. So we have a 300-degree angle. So let's draw, let's see, 90, 180, 270 over 30 more. Your reference angle closest way to the x-axis would be right here. So you do 360 minus 300. So your reference angle is a 60-degree angle. Last but not least, you have 870-degree angle. Now, I would find a coterminal angle first instead of drawing around a couple times. So if you subtract 360 from 870, you get 510. Again, that's over one cycle, so I'm going to subtract 360 again to get 150. So a 150-degree angle and an 870-degree angle, they're coterminal. So the reference angle would be the same. So we go over 90, not quite there, to 180, but we have our 150-degree angle. Our reference angle closest way to the x-axis. So we do 180 minus 150. Our reference angle would be 30. Okay? Let's see, what do we got left? Okay, so cosine of 30 degrees. Now this is the meat and potatoes. This is why we're doing this. So we're asked to evaluate cosine of 30. Now you could just type in your calculator, or we're going to use our special triangles. Okay? So cosine of 30, I'm going to go over 30, or up 30. Okay? So this is a 30-degree triangle. Can I zoom in? I don't know how with the way it's set up, which sucks. Can I expand this maybe? There we go. That'll be better. And we're just going to be in quadrant 1 for 30, so I'll cut off a little bit, but that's okay. So 30-degree angle. This is going to be 30. And so we're going to form triangles out of these. Okay? And so this one's always going to be a right triangle. Well, if this is 30, this is 90, this is 60. Now this is why we memorized our our special right triangles. Okay? Because we want to memorize the sides. Now remember, I told you x would be 1. So the side opposite of 30, the smallest side, is going to be 1. The side opposite of 60 is square root of 3. And this is going to be 2. Okay? So cosine of 30, now basically you plug in, cosine is basically a function, it is. You plug in an angle and it shoots out a ratio, okay, of the side lengths of that triangle that it would be formed. Well, cosine is adjacent over hypotenuse. So cosine of 30 is just square root of 3 over 2. And that would be your answer. Okay? I'm probably going to have to erase things here. So let's slide you over. Actually, I'll suggest you right here. So now we have sine of 225. So we need to go over 90, 180, 225. Now we want to calculate sine of 225. Now we're obviously not going to make a weird triangle, boom, boom. I mean, I don't even know. We're not going to do that. The reason why we talked about reference angles is because that's how you evaluate these sine functions. So you actually use their reference angle to draw the triangle. So the reference angle here, if this is a 225-degree angle, the reference angle would be this right here, right? And so you do 180 or nope, you do 225 minus 180, and that gets you a 45-degree angle. So we have a 45-degree angle, and so now I'm going to draw my triangle using my reference angle, okay? And so we're going to evaluate sine of 225 using this triangle made from the reference angle. Well, we know this is going to be 90, so this has to be 45 degrees. Well, our side length has to be 1, 1, square root of 2, right? However, if you're thinking of this on an XY graph, if you go to the left one, our X value is negative. If you go down one, your Y is negative. So it's actually a negative 1 and a negative 1. And so up above, sine of 225, well, let's look. Opposite is negative 1 over hypotenuse, which would be square root of 2. So you rationalize, you get negative square root of 2 over 2. Okay? And so we use our reference angles to solve these. So now I'm going to erase my work and do the last one. 5 pi over 3, again, let's convert. We did this on the last slide, it's 300 degrees. So you're going to go over 90, 180, 270. And so we need to find a reference angle. I should have extended that a little bit more, sorry. Which would be this angle right here. So you do 360 minus 300. Well, your reference angle is going to be 60 degrees. So we're going to draw our triangle. I know it's a little off, but that's okay. So this is 90. This has to be 30. Side opposite of 30 is 1. Side opposite of 60 is square root of 3. And then this is 2. However, let's see if this will let me move it. If you're going down on the height, if you're on an XY graph, this would have to be a negative value, right? So tangent is opposite over adjacent. So opposite of 60, negative square root of 3 over adjacent is 1. Okay? And so these would be your three answers. Now again, we're using our reference angles to solve these. Now it's important that we have our special right triangles down, because in all reality, our reference angles are always going to have an angle of 30, 45, 60, and in the next slide you'll see what happens if we're on an axis. Okay? So this is where it gets a little interesting, so I would pay attention. Now, if you're on one of the axes, so for instance negative 270, if you add 360 to that, that's a 90-degree angle, right? Or if you go down 90, 180, 270, so we have this angle right here, right? So it's coterminal with 90, so we have this angle. Now first off, if you're on the axes, if you're at 90, 180, 270, or 0 or 360, you don't have triangles, and we're not going to talk about reference angles because, you know, either way it'd be the same to the x-axis. And so we're just going to think of it as an XY graph. So if you have this point here, and this is a unit circle, let's say, so remember the radius is 1. So you go over 1 to on the x value, right? But you don't go up any. So your x value is 1, your y value is 0, and our r is always going to be 1 here. Okay? So our r is going to be 1. The distance here is going to be 1. So up here, r is 1 still, but our x, we don't go left or right any. So our x is 0, but our y goes up 1. Okay? Over here, r is still 1. Now you go over to the left on the x value, so it'd be negative 1, but you don't go up any. And down here, r is still 1. X, you don't go to the left or right any, but you do go down 1. Okay? And so we're going to use our x and y values here. Now sine, remember, is y over r. Well, at 270 it's the same as 90. our y is 1, and our r is 1. So it'd be 1 over 1, which equals 1. Okay? So let's look over here. Cosine. Well, cosine is x over r, as you wrote down. X is 0, r is 1, which equals 0. Okay. Now tangent is y over x. Well, y is 1, and x is 0. Uh-oh. You cannot divide by 0. So this we would call undefined. Now, if you plugged in tangent of 90 or tangent of negative 270, it would tell you either error, undefined, or something along those lines. So you can verify that with your calculator. And so when you're evaluating on the axes, you have to use these values. So we're really not making a triangle if it's on the axes. You're just using the fact that r is going to be 1, and then you have to figure out your x and y value. Okay, so I don't think that's terribly difficult. I think it's pretty self-explanatory. So even if we did a different, if we did cosine of 180, cosine is x over r, right? Well, the x at 180 is negative 1. R is 1, so cosine of 180 would be negative 1. Okay, so that's not terribly difficult, but it is important because in calculus, for instance, it could just be like cosine of 180, and they're like, you get negative 1, you're like, oh, well, what the heck? Since when did we know that? Well, that goes back to trig. Okay, so the most important thing that and being able to evaluate these, so we want exact answers. So obviously you could plug in sine of 225 in your calculator and get a value, but we're going to do exact values, okay? So I'm not going to accept decimals. So again, we use our reference angles. Now in this first problem, cosine of 30, the reference angle would be itself, right? So in quadrant 1, it is that angle. Now, an important thing to note, if you're evaluating, let's say, tangent of 300 pi or 300 degrees, sure, you're using your 60-degree angle to find it, but it's still tangent of 300 equals, what do we get? Negative square root of 3 over 1. So sure, we use the reference angle, but tangent of 300 does equal that. So we're using our reference angles to evaluate this. Okay? So I'm sorry this is a longer video, but this is the important stuff. So try these. A lot of these you can check your answers in the book. So with that, make sure you ask questions if you have them. Otherwise, thanks for being a good class. I know you guys are working hard, and I appreciate that. So I will see you guys tomorrow.